If you look up tonight, really look up, past all the city lights, you see this incredible view, right? Galaxies everywhere, billions of stars in each one. And you have to wonder, don't you, could there be some secret passage, a shortcut between them? Like a wormhole. That's what we're diving into today.
Exactly. It's a fascinating idea. We've got some great material here looking at, well, just how massive galaxies are, and then this really theoretical concept of wormholes. So our mission really is to unpack the science. What do we actually know? What's still, speculation? Hopefully we can give you a few of those aha moments without getting lost in the jargon.
Okay, let's start with galaxies then, our own Milky Way. It's almost impossible to really get your head around the scale. You mentioned it's got somewhere between, 100 and 400 billion stars?
That's the estimate, yeah. Think of it like a huge cosmic city. All that stuff, stars, gas, dust, and the mysterious dark matter held together by gravity.
But the really mind-bending part is the Milky Way is just one galaxy.
Mm-hmm. And there are maybe 2 trillion others in the observable universe. The number's just staggering.
Wow, 2 trillion.
And they're not all the same either. There's incredible diversity. You have spirals like ours, these big sort of blobby elliptical ones. You see galaxies crashing into each other. Somewhere stars are being born like crazy. Others that are, well, fading out.
And didn't the notes mention supermassive black holes too? At the center of many of them.
Yes, absolutely. At the heart of most large galaxies, including our own Milky Way, there seems to be a supermassive black hole. We're talking millions or even billions of times the mass of our sun. They have a huge influence on their surroundings.
Which points to some pretty extreme physics happening out there. It's not just static.
Not at all. It's dynamic.
Yeah.
Gravity's pulling everything around. Mergers happen. Black holes are active. It's a constantly changing universe.
Right. And that brings us back to travel, doesn't it? The distances are just immense. Andromeda, our nearest big neighbor, 2.5 million light years away.
Yep. 2.5 million years, even if you could travel at the speed of light. Which, we can't, not with anything carrying mass. So traveling between galaxies is orders of magnitude harder than even traveling between stars in our own galaxy.
Which makes the idea of a shortcut like a wormhole so appealing, right? Even if it's just theoretical.
That's the allure, definitely. The material describes them as these hypothetical tunnels through space-time itself.
The analogy was like folding a sheet of paper, so points far apart suddenly become close.
That's the one. It's a good way to visualize it. And interestingly, it's not pure science fiction. Your notes mentioned they're also called Einstein-Rosen bridges.
Yeah.
And they actually pop out as a mathematical possibility from Einstein's theory of general relativity. His theory allows for them, mathematically speaking.
Okay, so the math works out potentially. But have we ever actually seen one?
Ah, well, that's the big catch. No. Absolutely zero observational evidence. They exist on paper in the equations of general relativity, but not as far as we know in reality.
And there are problems even with the theory, right? Like stability.
Huge problems.
Yeah.
Stability is a major one. Most theoretical wormhole solutions suggest they'd be incredibly unstable. They might snap shut faster than anything, even light could possibly travel through them.
Snap shut. Okay, so not very useful for a spaceship then.
Not really, no.
Yeah.
And then there's the other really weird requirement the sources mentioned, this exotic matter.
Right. That sounded very sci-fi. What is that supposed to be?
Well, it's hypothetical stuff. To prop a wormhole open, to counteract gravity's tendency to collapse it, the theory suggests you'd need matter with negative energy density or negative mass. Think of it like anti-gravity, pushing things apart instead of pulling them together.
Does that exist?
As far as we know, no. We've never observed anything with those properties. So you need hypothetical matter to stabilize a hypothetical tunnel. It's quite speculative.
Definitely keeps it in the realm of theory for now. But, science fiction loves wormholes, Star Trek, Interstellar, Doctor Strange. They use them all the time as instant travel routes.
They do. Sci-fi often takes the core idea, the shortcut, and runs with it, usually skipping over the inconvenient stability and exotic matter problems.
Makes for a better story, I guess.
It does. But what's cool, as your notes pointed out, is that connection to real physics. Carl Sagan talking to Kip Thorne about wormholes for the novel Contact.
Yeah, that was fascinating. Thorne's a Nobel laureate, a top physicist. So even serious scientists have thought about the possibility, even if it was for fiction initially.
Exactly. It shows the idea isn't completely random. It has roots in real theoretical physics, even if it's way out there.
So let's ask the big question then. Could we actually use one to travel to another galaxy? I mean, assuming we found one and it was stable.
Okay, yeah, assuming a lot there.
Yeah.
But let's play it out. The challenges are immense, as the material highlights. First, you'd need to know where it goes. Does it connect to Andromeda, or just dump you into empty intergalactic space, or maybe even somewhere dangerous?
Good point. A shortcut to nowhere isn't helpful.
Then stability, we talked about that. How do you keep it open? How do you navigate through it? What are the conditions inside? Intense gravity. Radiation, we just don't know.
And the energy need, I imagine creating or controlling one would take, well, astronomical amounts of energy.
Probably unimaginable amounts, yes.
Yeah.
Far beyond anything we can currently harness. So the hurdles are significant.
But if we could,
Right.
wow, the potential is just staggering, getting to Andromeda instantly instead of millions of years, exploring other galaxies.
It would completely revolutionize everything we know about the cosmos, about our place in it. It would open up literally trillions of star systems to potential exploration. Colonization, maybe? Contact? It changes the game entirely.
Stepping back a bit, looking at the bigger picture,
Sure.
even without wormholes, the universe is just vast. And it's expanding, right? Galaxies are getting further apart all the time.
That's right. The expansion of space itself means that distant galaxies are receding from us, some faster than the speed of light relative to us. So some parts of the universe are already effectively unreachable by conventional means, no matter how long we wait.
So maybe wormholes, or I don't know, some other physics we haven't discovered yet, could be the only way to ever explore those truly distant regions.
It's a possibility. It highlights how much we still don't understand. Wormholes remain this tantalizing, thought-provoking idea at the edge of known physics. They push our imagination, which is always valuable in science.
It really does all come back to scale, doesn't it? The sheer size of it all and the mysteries still out there. Whether they're real or just equations on a page, wormholes make you think.
Absolutely. And maybe that leads to a question for everyone listening. When we think about all this, the trillions of galaxies, the mind-bending distances, these theoretical shortcuts, what's the one thing that really sparks your curiosity the most? What grabs you?
That's a good thought to leave people with. Well, thanks for joining us on this deep dive into galaxies and maybe, just maybe, the tunnels between them. Tonight, when you look up, remember those trillions of cosmic cities out there? Think about the immense distances and the profound mysteries, and consider the possibility of discoveries we can't even imagine yet. Maybe stable wormholes are out there. Maybe something even stranger. Our understanding is really just beginning, isn't it?
It really is. And it's that drive to question, to explore, that pushes us forward. Hopefully this chat gave everyone a fresh sense of wonder about the universe.
Until our next deep dive, keep looking up and stay curious.